So we were trying to support them as best we could at this time. It was a little bit more subjective in terms of the categories. And what I mean by that is if I switch over here, as you can see, the product for the first 24 hours was broken down into 6-hour chunks. So for instance, on the example I have, on the 13th, it would go from 12Z to 18Z, 18Z to 0. So you see these 6-hour chunks. And then we have a little bit of categories here. You know, and this is all probability based. So you're talking about percentages here. So we have, for instance, like a 10% of no snow, trace some more 1, 3, 6, and 10. And these were not really correlated at the time to the operational needs of the airport. It was kind of what we thought that we would try to give them a product that might be helpful for them. And it was helpful for a while. But as the operation started to evolve, as the airport started to grow, it became less operationally significant. So as you can see, we have that first 24-hour section, and then we have the long-term 48-hour section. And so this was all based on forecaster input. The forecaster sat down at their IWAWS machines, and they inputted this information every 6 hours. They updated it. So how did we go from that to where we are now? Well, enter the Global System Division. Over where we work here in Boulder, we have a plethora of research branches within NOAA and outside NOAA at our disposal. And it's a great collaborative environment. So GSD lives in our building, and we were talking to them, and they were actually in conjunction and working with NCAR on a project to see operationally significant probabilistic information for Denver International Airport. So they were aside working on this project. So we decided, as the Boulder office with our new SU, Paul Slaughter, to jump in at this opportunity and see if we can work with them to revamp our probabilistic snowfall product. They were doing a lot of the legwork when it came to operations, talking to the operators, at the actual snowplow people that are doing the work. And so we're able to get a great perspective on what is actually operationally significant for them. So these two entities in our building, Global Systems Division, out of the Earth System Research Laboratory, they improve presentation and the use of probabilistic information in the product itself. We were able to work with them to actually see how well some of this information came out. And they also worked with us in the programming aspect of the tool that we use at Boulder, and you'll see that product here in a little bit. And then NCAR, they did a lot of the social science part of this. They did a lot of in-person interviews with not only the operators, but with the operations staff and how they actually go about making these decisions. And they did tag-alongs with plow operators, which is one of my goals before I retire. But it was a great opportunity to get some one-on-one information from the people doing it. So not to get too much into the weeds with how a big, large airport deals with snow, but I just wanted to give you a little taste of what came out of that research. On the left side, we see the pre-event planning, and that happens well before. These decisions rely solely on forecast information, and they just don't use like weather service products. They use private weather. They use a lot of different resources to try to determine the forecast that they're going to use for their operations. So there are two major decision points on this. The first one is whether to declare a snow alert, and if so, what level and when it should start. It's pretty self-explanatory. You know, what type of snow event are we looking at? How operationally significant is it going to be? And when is it going to start and stop? And then, of course, the second one is whether and when to pre-treat. So as we know, with a lot of snow operations here in the Intermountain West, there's a lot of pre-treating that happens. But that's also based on what type of precipitation falls. Is it frozen? Is it not? You know, so it's a lot of what chemicals to use. That goes in. That's also something that they deal with at major airports as well, because they're dealing with a lot of paved surfaces. So the second part of this is tactical decision making. This happens while the storm is actually happening, and it's cyclical, and we'll see that. Managing snow and ice that has started to accumulate or will accumulate within the next few hours. Snow and ice management decisions include, you know, like we've already talked about, whether and when to close a runway. Is it falling so quickly that they need to close down a runway to get the snow off and then reopen the runway once it's safe and then close another runway? So how does that timing work? Where and when to apply liquid solid chemicals or sand? What kind of supplies do they need to utilize? what equipment to use. They have a very large army of tools and equipment at their disposal. So what kind of equipment should they take the time to get out of storage? Whether to close runways completely or close the airport completely. If it's just falling so much that they can't maintain, that's a very operationally significant decision that a lot of major airlines are going to have some input in. So that's, they have to really manage all that at the same time. So there's a lot that goes into it that I really wanted the product to help with, as well as the situational awareness of our forecasters. So pre-event planning timeline, 3 to 7 days out. They're monitoring, like I said, various forecasts, not just ours, but various other forecasts, trying to see some kind of a collaboration output. And then, of course, within like 48 to 72 hours, those start to converge. So 1 to 2 days out to the event, they continue to monitor things, and they develop an operations staffing plan. And this is where everyone comes together in the operations department at a major airport, specifically DIA, and they start talking about the forecast, going through them, speaking with meteorologists, trying to figure out a plan for that event. They said 10 a.m. in the report, but typically it's about 8 to 12 hours prior to when the snow event starts. So obviously that'll fluctuate. But they make that snow alert decision. And so this is when operations personnel hold a forecast briefing call. And sometimes this is mainly with their private weather companies that they pay to be a little bit more involved in their forecast. But they also call the Weather Service office as well and try to get that perspective. And they did mention in the report that talking to a forecaster is always very helpful with this sort of perspective because confidence does come into play in this. And we to try to determine that snow alert level for the event. And then, of course, towards the end of it, you have the snow starting to accumulate, and that's when decisions need to be made, and they transition to the tactical stage. So, tactical decision timeline, and it's a cycle, really. It just continues through this whole period as the snow is falling. So you have snow or ice beginning to accumulate. So they're taking observations, they're taking snow depth, they're taking outside temperature and wind speed, snowfall rates is really huge, and they're continuing to absorb this information and changing things as it happens. Because obviously, as you know, if you forecast in the mountains, snow forecast doesn't always come out as planned. So they're constantly trying to change their operations plan throughout the event. So snow and ice is falling, a cycle of information through operations staff that makes these tactical decisions as they go along. Runway closures, formation changes, temp treatment practices, this all is fluid. So when to close the runway, that's a decision point. How to remove snow and treat the runway, that's a decision point. And check runway friction. This was an interesting one for me. I didn't really think about it as a forecaster. Surface friction is huge. Obviously, planes can't land if it's too icy, they'll just slide. So that's another thing that they need to figure out before they reopen the runway. And then ongoing is those airfield conditions, forecast updates to include our PSA product and what we put in there. And then also the private weather companies that they talk with. So this is just kind of a taste of what that NCAR report had. And it was a lot of really great information that we wanted to put. So we pulled out of that, assessed the needs. What is the nuts and bolts of what they need from us? And that's predicting snow accumulations on paved surfaces. Now, this was a good reminder for us, because a lot of time when you talk to emergency managers or you talk to partners and you talk about snowfall, you're like, okay, this is how much you can expect. But we don't really think about melting. In a lot of paved surfaces, there's going to be a lot of initial melting, especially in the springtime when temperatures might not be as cold to start. So we had to really keep that in mind, because they honestly don't care about snow on grassy surfaces. They want to know what's going to fall on the concrete. So we had to take into account runway temperatures, and that was an MDSS product, so that was an outside product. So there's a lot of things that went into that. Predicting amount of snow accumulation at thresholds. Now, these are their actual alert thresholds, which was important for us to understand. 1 inches, 3 inches, and then 10 inches. They said they're at max at 10 inches. Everybody is on deck for 10 inches. So anything above that, they really don't care. Because if they're sitting at 10 inches, everybody's there anyway. Start and end times for snow, for obvious reasons. Likelihood of heavier or lighter snowfall rates. And I think a lot of people already understand that. Higher the snowfall rate, it's going to be harder to get that snow cleared and to keep the runways open. So lighter snowfall rate, it's more manageable. Possibility of surface temperatures dropping below freezing. Pretty self-explanatory. If you drop below freezing, that snow and ice is going to accumulate a lot faster. Wind speeds. We get a lot of high winds sometimes with our snow events here in Denver, and so we get blizzard conditions. And you know, plows have gone out before, and they've not been able to find their way back. They get lost out because Denver International, unlike some other airports, is so incredibly large in its space that plows can get lost if the visibility is too low. So that's something that they care about as well. So what did we do with all this information? Well, we turned it into this. This is the GUI that we see, that the forecaster sees. Obviously, it's packaged a little differently on the other side, and I apologize I wasn't able to get a snapshot of that product, but this is what we see. So as you can see, we still have the short-term discussion section, which is 24 hours, and then outside of that, we have that long-term discussion, which is out to 48 hours, so that hasn't changed. But as you can see, we went from 6-hour blocks to 3-hour blocks. That's that first red circle on the left. So we took that 6-hour time period and we minimized it to 3 hours to provide them a little bit better of a time frame for when that heavier snow might fall, because that's important operations. And what I wanted to note is when we worked with GSD, we worked with a man named Thomas LeFay, and I know a lot of you guys probably know him. He does great work with the new Forecast Task Builder product. But we worked with him to develop this, and he actually was able to incorporate a time-lagged ensemble model product into this, and that's the second circle there. As it says 18 members. Well, those are models, and it actually is able to include our official forecast in that ensemble, as well as other models like the GFS, the National Blend, the RAP, and it takes that QPF forecast from each one of those models, and it multiplies it by our official snow ratio grid in IWAWS. And it takes it from that 3-hour block, and it's time-lagged. And that's another thing I wanted to make sure I noted, was that it's a time-lagged ensemble, which, I mean, a lot of you already know, but it means it finds all the forecasts valid at that particular forecast time, no matter when that model runs. And it takes that ensemble average, and we can click on that, and it actually moves those bars to that output for us. So we can see what we want to put, and we can see the ensemble. And so it gives us a great perspective on that. And I think that was a great addition to this product. And I did want to also note that they are equally weighted. So obviously, earlier forecast times have more members, roughly average 12 to 18. Later forecast times have fewer. So, working with Tom was great in development of this, and that addition, I highly recommend for people that are looking forward or looking towards developing some product for their airport, and developing that ensemble and incorporating that was a great addition to this. And obviously, with any new type of product, we try to pull in a lot of what the research showed. And so in that discussion, we were able to work with the forecasters and talk about, okay, this is what they care about. This is what you need to focus on in your discussion. And that was also another side improvement with this research and project. We were able to better collaborate with our DIA partners about their needs and create another bridge to that partner. So looking ahead, what does this look like? Well, as we know, feedback evolution. We talk to them, we try to meet with them after every major snow event, and we try to get feedback. What worked for you? What was not as helpful? What could we have done better? And in these interactions, we're building that relationship. That collaboration is crucial, not just with the product, but in everyday operations. So the product was a step into that as well. But we're continuing to do that. This year was the first winter season that we utilized it. We did get some good feedback from it. We're looking to hopefully get another winter season coming up and get a little bit more feedback. Obviously, everything got a little wonky towards the end there. But we do look forward to utilizing this product next winter season and getting some additional feedback and making some changes as needed with our GSD partners. So speaking of partners, I wanted to go ahead and take an opportunity to send a special thank you to the Global Systems Division, Tom LeFay, for the GUI development, and the team leader, Mike Cross, the National Center for Atmospheric Research. Rebecca Morris headed that team that did all that great social science research with DIA operators, provided a lot of the meat of this product. And then, of course, at Denver International, Dave Cunningham for being our partner in this. But yeah, barring any questions, that's what I have for you today. Thank you so much.
Thank you so much, Kari. Is there anyone who has any questions? You can enter them into chat now, and I'll pass them on to Kari. All right, well, I don't see any questions coming through. Kari, you must have done a great job over there.
Well, thank you so much. Yeah, if anybody has questions or they're looking at doing something in the future, you have my email, so feel free.
Exactly. We will be passing along the information and the recordings as well. I'm going to go ahead and stop recording this, and then I'm going to be passing it over to Phil, Dr. Schaefer there. We hopefully have everything